Question 23. A continuous random variable, x, has the following probability density function. f of x equals sine x for x greater than or equal to 0 and less than or equal to k, and f of x equals 0 for all other values of x. Part A. Find the value of k. A continuous probability density function behaves in a similar way to a discrete probability density function, and it's valid if and only if function x is greater than or equal to 0 and less than or equal to 1, and the integral from a to b of f of x dx equals 1. This is similar to a discrete probability density function where the probabilities of all the outcomes, that's p of x, must lie between 0 and 1, and the sum of all the probabilities must equal 1. Now the integral from 0 to k of sine x dx equals 1. We want to solve for k. The integral of sine x with respect to x is negative cos of x, and the limits are from 0 to k, and that expression equals 1. Expanding the brackets and applying the limits, we have negative cos of k plus cos of 0 equals 1, and cos of 0 equals 1. So negative cos of k plus 1 equals 1, and subtracting 1 from both sides, we have negative cos of k equals 0, multiplying both sides by negative 1, we have cos of k equals 0, and therefore k equals pi on 2. Part B. Find the probability that x is less than or equal to 1. Give your answer correct to 4 decimal places. The probability of x less than or equal to 1 is given by the integral from 0 to 1 of sine x dx, and that equals negative cos of x from 0 to 1. Expanding the brackets and applying the limits, we have negative cos of 1 plus cos of 0 is equal to 0.459697, and so on. Rounding that value to 4 decimal places, that equals 0.4597. Now, as a side note, for both parts A and B, ensure your calculator is set to radians when working with calculus involving trigonometric functions.